My name is Muhammad Tahnaim. I am your chemistry teacher. Today I will teach you the topic that's atomic orbital hybridization. What is the importance of atomic orbital hybridization and where we study the atomic orbital hybridization? And what is the SLOS of atomic orbital hybridization? So we move to our today topic, that is atomic orbital hybridization. So following SLOS of atomic orbital hybridization, in today topic which we will cover, that is what is hybridization and what is the importance of hybridization and how to calculate the hybridization state of a different molecule, and also last one we discuss the types of a hybridization. So first of all we move to our topics. What is hybridization? Hybridization, that is basically that is a hypothetical phenomena which says that the unhybridized atomic orbital states that what you mean by unhybridized, that's orbitals which are in atomic state, that have a ground state level, that have original state of atomic orbital, that's called unhybridized. They will not be intermixed. That's an unhybridized atomic orbital intermixed to generate new equivalent. That's point is very important. Equivalent hybrid orbital. What do you mean by equivalent? Equivalent state that that's the resultant orbital when we unhybridized orbital intermix to generate equivalent. That equivalent means that the resultant orbitals which have a same in energy, shape but different orientation. What do you know now? What do you mean by same energy and shape? When we say that different orbital, we can see that that's 2s orbital and 2p orbital, 3d and 4f. We say that when we move from 2s to 4f, yeah, 2s to 2p, the energy state is increased. 2s in low energy state, p in slightly higher, and d in slightly more higher, and f slightly more higher than that of a 3d. That's a energy state. When that's two orbitals p and s that will be intermixed to generate a new hybrid orbital like sp. That sp orbital which have a intermediate state, that have equivalent energy, that's orbital not that's orbital which have not more energy than p orbital, not less energy than s orbital, that's intermediate. That stage is a equivalent, that both orbital s and p that will be equivalent in energy states. That's a equivalent. And shape, when we say that shape, what do you mean by shapes? When we say that s orbitals, that's s orbital in a spherical shape, that is a spherical. When we say p orbital, that is a dumbbell like that py, and same like that is a px, that is a dumbbell shape. When we intermix that's both orbital to resultant generate hybrid orbital, that hybrid orbital have a equivalent shape, that will be one is lobe is large and second one is a small lobe. That will be generate, that is a sp state of a same like when we intermix 1s and 2p, that's sp2. That will discuss in the further topics. So here I can explain the topic is the intermediate state are equivalent shape and same energy orbitals, different orientation means this in this space the orbitals have a all the sp orbitals, hybrid orbital have same orientation in a space. So one question arises here is that which orbital intermix? That orbital intermix in which in hybridization state which have a same or a nearly same in energy, like s, 2s and 2p. That's orbital. That two orbitals which have slightly energy difference, not more than energy difference, like 2s or 3p. When we say that 2s and 3p, that's orbital intermix is not possible. Second one, so that's a hybridization state. What is hybridization? And second one is the importance. Why we study हाइब्रिडाइजेशन, हमें हाइब्रिडाइजेशन पढ़ने की जरूरत क्यों पेश आई? द रीजन इज दैट द हाइब्रिडाइजेशन कैन बी स्टडी या ओवरकम वन ऑफ द ड्रॉबैक ऑफ अ VBT. VBT have a following drawbacks. VBT does not explain the coordination complexes, that also does not explain the magnetic behavior, and also does not explain the equivalent tetravalency of carbon. Same like VBT does not explain the beryllium. Beryllium, and that according to VBT says that partially filled orbitals, partially filled, half filled, outermost या valence shell orbital to overlap to form of a sigma bond or a covalent bond. When we say that beryllium have a no partially filled orbital, that it means that behave like a inert like behavior. Same like boron form of a one partially filled orbital, one half filled orbital, that form of a one sigma bond, and carbon have a two partially filled orbital that form of a two sigma bond according to VBT. But actually when we can see is that that's not happening, and that also not always explain the valency of a central atom. So that's drawback will be overcome with the help of a hybridization. How to help overcome that drawback? By that drawback removed by Pauling and Slater to introduce the term hybridization. Term when introduced the term hybridization, that explain the equivalent tetravalency of carbon, and also explain the satisfactory give answer about the valency of a central atom. Like central atom is a beryllium form of a 2 sigma bond that exists in the salt form is a BeCl2. That will successfully explain with the help of hybridization. And boron form 3 sigma bond in the case of a boron trifluoride, and carbon form of a 4 sigma bond like CH4. That will answer by Pauling and Slater with the introduction of a term hybridization. Hybridization, that's a so unhybrid in that case, that's a that term which is introduced by Pauling and Slater, hybridization. So that's why we study hybridization term. And second one is the important things, how to calculate the hybridization state of any molecule with the help of a hybridization phenomena. That will be used to that will be calculated with the help of a following formula. One formula is the number of a sigma bond which formed by central atom plus lone pair of electron on a central atom. When we sum of that two term, we calculate the hybridization state of any molecule. And second formula is the Z is equal to half number of valence electron of central atom plus monoatomic atom के उसके साथ सेंट्रल एटम के साथ मोनोएटॉमिक एटम कौन सा है? जैसे कि अगर हम देखते हैं BeCl2 beryllium dichloride, that's a chlorine is a monoatomic that form of a one sigma bond, and same like hydrogen that's also monoatomic. It means कि first group वाले और second group वाले that's a monoatomic, and same like BF3 that's also one sigma bond बना रहा है, तो एक monoatomic है. कितने monoatomic है? अगर फ्लोरीन है तो इस केस में हमारे पास फ्लोरीन 3 है, तो इसकी वैल्यू क्या होगी? 3 होगी. प्लस क्या होगा हमारे पास? नेगेटिव चार्ज पूरे कॉम्प्लेक्स के ऊपर. अगर ये सेंट्रल एटम जैसे कि आयोडाइड है, उसके ऊपर नेगेटिव चार्ज कितना है, उस नेगेटिव चार्ज को ऐड करेंगे मैंने पॉजिटिव चार्ज. अगर सेंट्रल एटम के ऊपर केटाइनिक चार्ज है, उसको क्या करेंगे? सेपरेट कर लेंगे. तो उसके ओवरऑल रिजल्ट जो हमारे पास Z की जो वैल्यू आएगी, उससे हम क्या कर लेंगे? हाइब्रिडाइजेशन स्टेट किसी भी मॉलिक्यूल की कैलकुलेट कर लेंगे. हियर आई विल गिव यू वन एग्जांपल लाइक दैट इज अ water. When we say that water is, what is the hybridization state of a water? Z is equal to, in that case central atom is a oxygen that have a atomic number 8. In that case we can see that oxygen with the 2 hydrogen, it means that oxygen form of a 2 sigma bond, number of sigma bond is 2, plus oxygen have a 2 lone pair of electron, 2 lone pair of electron. Z is equal to 4. When Z value is 4, it means that hybridization state is sp3. Z की वैल्यू स्टार्ट होगी हमारे पास 2 से अप टू सो ऑन. अगर 2 होगी तो sp, 3 होगी तो sp2, एंड अगर Z की वैल्यू 4 आएगी तो दैट्स sp3. So that how that's the formula we use to calculate the hybridization state of any molecule. In the further next lecture, I will calculate the hybridization state of with using that formula. And second, in the new topic we will study in the next lecture, there is a types of hybridization: sp3, sp2, sp, and dsp2 or dsp3 up to so on. That's the different hybridization state of different types of hybridization. That's topic today which we will study in that lecture. If any question, you comment below the section.